Today on the bench we're playing games. We've got a Sega Saturn. Here we go. Already doesn't look good. Somebody's been in it. Look at that. And checking the other side. Looks like we might have a screw at the back. The rear of the console, we can see it's still got the power supply screws, but the battery's been pilfered. And this screw's loose. Oh dear. Looks a bit iffy. That's interesting. It feels like it's screwed in, and yet the console is loosely together. Very unusual. So now we're laid of console flat, and hopefully the screws should just drop out. It looks like a fairly standard arrangement for a Sega Saturn. We've got a power supply, CD-ROM switch mechanism, CD-ROM board. I'm not familiar with this particular one. Here it is from the front, so we'll get this apart. So first up, we'll check the fuse. We'll get the multimeter probes in. Fuse is good. What we'll do next is we'll plug it in and we'll see if we get any kind of digital display output. We now have the console plugged in. Let's power it on in 3, 2, 1. Hasn't exploded. No response from the CD drive. And the power LED is not switched on. So the next thing for us to check is what the power supply is outputting. So we have the multimeter probes connected. Let's see what we get. We get 5 volts output. We're getting power to the system, but we're not getting any signs of life. Time to strip the board down. Now we've got this free to take the power supply unit out. We'll unclip this switch and then just pull the whole unit out. Next we'll remove the connectors for the CD-ROM drive. So we'll remove the power connector and the ribbon connector for it. Next we remove the CD-ROM drive. You lift it up and tilt it to one side to reveal one final screw. So we now have access to the gubbins of the console. I'm going to power it on, and that will limit it to 1.3 amps, and it'll inject 5 volts. So 3, 2, 1. That's about typical of a working console. And if we take a look, so we have changed behavior now. The LED is coming on, which implies that the problem was either the damaged ribbon cable of the CD-ROM drive, causing some kind of short maybe. What we'll do now is hook up the video output cable and see if we get any kind of display out on this unit. And as you can see, we do have video output. So the next thing for me to do is to hook up a game controller and just see if I can navigate through these menus. So the controller's fine. We get the Sega Saturn logo and everything looks okay there. Great. So upon inspection, I've realized that the ribbon cable is damaged. It's not usable, and that would be why the CD-ROM drive was completely unresponsive. So that implies that whoever's been in this system has decided to replace 3 capacitors on the main board, probably because it wasn't reading discs, and they thought that that would repair it. And then they've unplugged and replugged the CD-ROM drive several times, and it's had no effect on the overall system performance. So my working hypothesis here is that the only issue with this system is the CD-ROM drive. I've got this from another system I had lying around, so we'll plug that in carefully, unlike the last person. We'll grab the CD-ROM drive, and what I'll do, we won't be able to test this fully because the games I have are PAL region games, so they won't actually boot, even if the CD-ROM drive works. So that's something to bear in mind. But it should at least read it as an audio disc. And the CD-ROM drive is still completely unresponsive. Let's check that with the multimeter. 22 millivolts, -1, 1 volt. Okay, so the issue here then, the CD-ROM drive is not getting power. Each of these pins that I'm probing is getting millivolts or 1 volt, which implies an issue with this line. So we've got 5 volts there at this coil, 2 volts at this resistor, 2 volts at this resistor, 5 volts here. What we've observed then is on this connector that connects to the CD-ROM drive, all of the voltage rails were very, very low. We're talking fractions of a volt in most cases. So there's a connector we are going to probe. So we get 5 volts here, 2 millivolts, 0.125 millivolts, 3.3 volts, and millivolts again. So I think a few of these are ground, and I think we've got 5 and 3 volt rail. We can see the connector. Using my multimeter probes here, I've got them in continuity mode. We have a coil L10. That is the only passive component I can see between VCC and the drive. We have continuity on one side of this, but not on the other. Which means we don't have continuity across it. So what we're going to need to do is find a donor inductor, because I don't have any on hand. Here's our donor system. Connector 7 here. We have a coil, and we can check this coil. We should have continuity through it. We do. So that's a good coil. So to get this inductor off, we'll just use, this is the donor inductor, we'll just use a little bit of low melt solder. Mix it in. There we go. And that's our dead inductor off the board. So we cleaned up those pads nicely. And we'll just go ahead and solder this new one in place. What's happened is that CD-ROM drive at some point has probably pulled a little bit too much current, but it may have acted like a fuse. Too much current's gone through it and it's popped. What we'll do is we will connect the power supply and then we shall probe. Our multimeter in DC volts mode, we will probe at that connector again and see what we get. 5 volts. 5 volts. Okay. I believe that we've restored the functionality, so now we can test it with the drive. Let's see if the CD-ROM's responsive, and it is. We've restored power to the CD-ROM, tricked the system into thinking the door is closed. We can see it's attempting to get its focus and track lock. So if we put a game in now, the laser assembly moves, the CD-ROM drive does not spin. It is drawing current. To recap, what we've discovered: a blown inductor at the power connector for the CD-ROM drive. We've restored 5 volts. You may notice there's a connector here. And we've got a ribbon connector there. And then the power connector there. This board only has a ribbon connector and this, which means that this CD-ROM... And then what we can do is provide this with some power. So we'll just connect up our lab supply again. 5 volts to the 5 volt rail. And ground. This won't boot this game. The reason it won't boot it, this is a PAL region game, and this is a Japanese NTSC unit, Sega Saturn. If we power it on, jump at a bay draw, we now get disc spin, which is really positive. That's looking good so far. We can actually see that it is playing the music on the disc, so it's reading the discs now. So all we need to do now with this unit is region-free BIOS mod it, which will allow us to boot a game. We'll service the CD-ROM drive because this one's a little bit noisy. If you listen... So the drive doesn't sound overly clever. This is from a donor system though. That should be enough to get this unit up and running. So I'm going to call this a fix. Let's get it serviced and let's get it modded and then back together. And we should see that it then boots. This is a donor CD-ROM drive. It's not from the console that I just repaired. This is from another unit and it is the correct CD-ROM drive to use with that particular unit. The drive that came with it was not faulty, it's just for a different model of Sega Saturn and is incompatible. So what we're going to do is use this compatible one, but in the case of this unit, it needs a bit of refurbishment. It's a bit loud, it's a bit dusty and full of dirt and grime. So we're just going to clean it up and get it up and running nicely again. So what we want to do is just wet the whole unit with isopropyl or whatever and just wipe it down. So you can see here I'm wiping it down. Come in with the bottle of oil like that get it right up against the base of the spindle, and you just want to get a tiny amount of oil out, maybe a drop or two. So that's quite a lot, and then you just want to work it in. So just spin the spindle. And what I usually do is I use about 2 drops of this, so I'm going to repeat the same thing again. This is the next motor we want to oil. There's only 2 on the board. So now we have the Sega Saturn laser pickup. And then the next thing to do is to take this top plastic piece off. For this we will need some compressed air as well, and to get that off you'll see there's some retaining clips. One here where my tweezers are, and one here where my tweezers are. And that's it. That's the laser pickup partially disassembled. We're not going to fully disassemble this, we don't need to, but you can see now that we've got access to the interior. So a drop of IPA on top like that, just a single drop's all you need. And that looks good. And what we're trying to do here is really blast out all of the crud. And then finally what I will do is 1 more drop of isopropyl alcohol on the lens itself. Just a single drop is good enough. And that's it, that's done.
Lunch, Lady Doris. Have you got any grease?
Yes.
Then grease me up, woman!
I'm just going to flood these gears with a bit of IPA, and for these it's probably better to use a brush because a brush can get into the teeth. So the next thing to do is to take the old rail and just clean it off, because the old grease may be a little bit dry, it may be have lost its effectiveness and so on, so on. So what we do, just take a paper towel, wet it in isopropyl alcohol and just give it a good clean down. So then along the guide rail we just apply a little bit of white lithium grease. And then we just slide the ribbon connector back in and lock it into place using the tabs on the side. So it's just a case of close the tabs. And that's it. So again, it's just a Q-tip with a little bit of white lithium grease on it, if I can pronounce it.
Me fail English? That's
We come in
impossible.
and we just So just a quick pointer, I actually assembled this slightly incorrectly, so what I'm going to do is just push this rail back out, and I'm going to pull this direction a little bit and pull the whole sled out just a little bit like that, just so we can move that out of the way. And then I'll add this gear, and then I will come back and slide this back into position again. So we slide the rod back in, lock it into position, and now the mechanism should work correctly. So you lastly need to just clip this in. And that's it. That runs very, very smoothly now. We should see the date time, and we do. So we'll just navigate through the menus. We'll let the Saturn boot up. And now we should be able to hear a major difference in the audio. So it's time to get the CD-ROM drive running. This is how it sounded and performed before servicing. .5 seconds. Bit of a slouch. Quite loud and noisy too. Now here it is after being serviced. Now I've noticed straight away it's loading the table of contents of the disk much quicker. We can't play this game until I do a region-free modification on this unit. This unit is now up and running again. Now the next thing we need to do to get this to boot games, to boot PAL region games, because it's an NTSC console, is to remove this guy. And then replace this guy with a electronically erasable and programmable read-only memory. This is just a read-only memory. It's programmed at the factory with the BIOS. We have the region-free BIOS ready to go and prepared on a EEPROM. Getting this off is pretty simple. So the next step is to get our new chip and solder it in place. These are chips that I've programmed myself. They are byte swapped. And what you can see I'm doing here is just tacking the pins. And by doing that, we stop the chip moving around too much. And what we're trying to do is get the iron to do all of the work for us here. And really we're just trying to get the solder to flow under the legs slightly to make a connection. And we can see that these have made good solder connections. These should be floating. I will lift those pins. So that first pin is not soldered. And that is now solidly soldered, and they all appear to be. So we can now lift these. What we want to do with these two pins is actually bridge them together with a blob of solder. So we'll just lift them a little bit higher, there we go, and we'll come in with our iron and some solder. And on the other side we want to lift these two pins. Bend the wire, bend it up. And there we go, I'm satisfied with that now. So there we go, console is almost ready for another test. We just need to hook up the power leads. Okay, we can see right away we've got the new BIOS, because it's giving us language selections here, so we select English. So we know right away we can already see that boot screen's slightly different. If we now trigger the disk drive, start application, we should be good. Let's see. These systems do take a little while. Prepare for battle. So the Saturn's drawing around about 7 watts. I don't know where I am here. Where am I? Am I one of these characters? Yeah, I'm the guy on the right. Hard to play with one hand, but there we go. So we know that this Saturn works. It's got a region-free BIOS now, so it can play games from any region. It might be a little glitchy with them, because in this case it's a PAL region game on a NTSC system, but it seems to be running mostly okay. Well, there we go. That's the bulk of the work done. The repair's been done. So things we discovered. Ruined ribbon cable. Incorrect CD-ROM drive. and there was a blown inductor on one of the main power rails that feeds the CD-ROM drive. Whoever opened this up previously was probably trying to fix the blown inductor, didn't know what to look for, probably had other broken Sega Saturns, and most likely just put this together with parts that they had nearby, and that included one of the incorrect CD-ROM drives. That's fine, I had a donor ready and left over from another system that's dead, that's unrecoverable. So there we go. We got it fixed. Thanks for watching. Don't forget to hit the like and subscribe button. If you think I could have done anything differently, then just add that down below in the comments, and I will see you next time.